Okay, so welcome to Math 140 Science. This is lecture number 12 in week number 7. And we are starting with chapter 16 on confidence intervals. And confidence intervals are one of the two major topics for the second half of the course, the other one being what's called hypothesis testing. And hypothesis testing and confidence intervals from a theoretical perspective are two completely different things. So in the case of a confidence interval, this is the main idea. We know, or should remember hopefully, the difference between a parameter and a statistic. Someone remind me, please. What's the difference between a parameter and a statistic? Hi, Mariah. How are you? Welcome. Do me a favor. I'll do attendance now. Okay. So what is the difference between a parameter and a statistic? Anyone, please? Nobody? This is important. Yes, a parameter is a number that describes the population, as opposed to a statistic, which is a number that does what? Describes the sample. Right? Parameter describes a population, a statistic describes a sample. So for a confidence interval, step one, you want to know an unknown parameter. You wish to know an unknown parameter. So what do? You take a sample. And that sample will be of some size, of size n. And one of the questions that we're going to be asking in this chapter is, well, how do I figure out what n is? But for now, let's not worry about that. You take a sample of size n. And the goal is to, so what do you do with that sample? You use that sample to measure, or you measure a statistic. You measure a statistic to approximate the parameter. So suppose you were interested in measuring the average weight of every CSUN student. So there's 40,000 some CSUN students. Measuring the weight of 40,000 people, or the average weight of 40,000 people, is kind of tough. It's going to take a lot of time. And by the time you've done, half of them will have graduated or lost weight or gained weight. And so it's not really practical. So what do you do instead? You take a sample. You know, you go to the quad out there by in front of the library. You take an SRS, ideally a random sample, simple random sample of, let's say, 100 people, and you measure their average. Where do you keep these? Okay. You measure. Thank you. You measure their average, and you now have a statistic, right? In our example, I'll use a different color for this. In our example, the parameter is equal to the mean, to mu, and the statistic that we use to measure the parameter we're calling x bar. Or perhaps we have p, a proportion, the proportion of students on campus who, let's say, work out, and we take our statistic, which is p hat, which is our approximation for the number of students on campus who work out. Now, if you got an X bar, of, let's say, 190 pounds, would you say definitively that the average weight of every CSUN student is 190 pounds? Would that be your conclusion if your sample gives you a value of 190 pounds? No, because we know that samples are only approximations. So when you get your statistic, X bar, we're going to try to create an interval around it. And we're going to say that we have a certain amount of confidence that the true value is somewhere inside of this interval. So we're going to add some unknown number currently. We're going to fill this in later. And we're going to subtract that same unknown number, and we're going to form a confidence interval. Or similarly, you take your a sample proportion, and then you add and subtract some number to create a confidence interval. These intervals, let's go back to blue. So you form an interval about your statistic. And conclude with some confidence level that the unknown parameter is somewhere in that interval. So is the procedure, is the approach, without getting into the details about how we do it, but is the approach, is our task that we have set out for us today, does it make sense? Is it understood? Everyone else? Okay. So now, question for you. What should the size of your interval depend on? What are some factors that would influence how wide your interval that you create is going to be? Anyone? Guess. What are some factors? The size of the data. So definitely N, the sample size. In fact, let's be more specific. As N increases, does the sample size, does the interval size get bigger or get smaller? Do you think the interval size gets bigger or gets smaller as the sample size increases? Remember what your goal is. Your goal is small e. Small e, is that like a character from a movie? Yes, smaller. As N increases, the interval gets smaller. And let's understand why, and make sure we understand this. The goal of this process is to narrow in on your parameter, right? Mu is somewhere in, right? Mu is somewhere in here, or P is somewhere in here. The true value is somewhere in your interval. Ideally, that interval is so tiny that we know exactly where your parameter is. So as the sample size gets bigger and bigger and bigger, ideally we want to hone in on the true value so that the uncertainty shrinks. Does that make sense? Okay. Give me something else that you think might affect the size of the interval. Other ones might be a little harder to think about, but give it a shot. What's something else that might affect the size of the interval? Anyone have an idea? So the next one is the standard deviation of your population, how spread out the original population is. If the original population is very spread out, you should expect that the uncertainty of your guesstimate should be pretty spread out. Where if the uncertainty is very small, so it's a very tightly, well-defined population, then the size of your uncertainty should also be small. So as the standard deviation increases, the interval gets larger. More uncertainty, wider interval. Seems reasonable, correct? At least once it's pointed out to you. Yes? Anyone? Bueller? Okay. The third one is how confident you want to be that you caught it. If I require 99% confidence and you only require 80% confidence, one of us can be a little looser with our sample size. So as the confidence increases, confidence of what? Of catching the parameter. As the confidence of catching the parameter increases, the interval gets what? Larger or smaller? I have a vote for smaller. Does everyone agree? I have a vote. Oh, we got a fight going on here. Someone says smaller, someone says larger. Anyone want to break the tie? Why do you think it's larger? Ooh, smaller. Uh-oh, 3 smaller against 1 larger. 1, 2, 3. Oh, larger took the lead again. 3. Oh, no, now it's tied. 4-7, larger wins. It's like the World Series. Larger is correct. The bigger it is, the more the interval contains, right? And better chances of getting the parameter. That's exactly it. That's exactly it. If I want to be 100% confident that I caught it, why don't I take the interval from negative infinity to infinity? Take the huge interval. If you want to be 100% chance to catch it, take a humongous interval. You're certain to have caught it then, right? The bigger the interval, the more confidence that you caught it, because you have more room. Your net is larger. So a smaller confidence level translates to a smaller interval. Does that make sense? So those of you who said yes, who said smaller, hopefully that makes more sense. Why bigger confidence means larger. So in this class, we don't derive formulas. for a lot of what's coming. We just give them. So I'm going to give you right now 2 of our basic confidence interval formulas. If the parameter is mu with statistic sigma, the confidence interval is x bar minus z star sigma over the square root of n to x bar plus z star sigma over the square root of n. That's our formula. Sorry, I didn't mean statistic sigma. I meant statistic x bar. So please fix that. Now, of course, if I want to use this formula, I better know what everything means. What does x bar stand for? Be more specific, please. This is the sample mean. Okay, very important. Remember, this is also a mean, right? Mu is the actual mean. The actual mean better not appear in my formula because I don't know it. If I knew it, why am I taking a sample? So the actual mean does not appear anywhere. So x bar is the sample mean. Okay, what is n? So easier to harder. What's n? The sample size. What is sigma?
Standard deviation.
Standard deviation of what? Of what?
Of the sample mean.
Sigma is Greek. So standard deviation of what? Of the population. Now, of course, you might say, wait a second, hold on there. If I don't know mu, why should I know sigma? And the answer is, you're entirely correct. Sometimes you don't. In which case, we have a different formula that we would use where everything else is exactly the same. But since we don't know sigma, we have to replace it with something that we do know. What's a good thing to replace sigma by when we don't know sigma? I don't write the second formula down yet because I got to make one change. So if you're writing with pen, let me already wrote it. I'm sorry, I'm going to make one change. But it seems like if you don't know sigma, we need to replace it with something. Now you said x. What exactly is x? No, Luis got it. It's the sample standard deviation. If you don't know the actual standard deviation, well, the next best thing to replace it with is the sample standard deviation. However, when we do that, we actually, unfortunately, have to replace Z star with something called T star. Now at this stage, whether I write Z star or T star, hopefully you have a very appropriate question which you can ask right now. What is a really appropriate question to ask right now before we do anything else? what is Z star? And what is T star? All right, these are great questions to ask, right? I know what everything else is standing for in these formulas, but I don't know Z star and I don't know T star. So Z star is the Z score for whatever confidence level you choose. T star is the T score for whatever confidence level you choose. Now, did I really answer the question? Well, not really. And I mean, yes and no. I explained what Z star is, but I really still haven't explained how to get it. So let me give an example for both of these so you see it in action. Give me a certain level of confidence. Pick a certain level of confidence. I don't care what level. Well, not 100%. Okay, I heard 90%. I saw 80, I saw 90. I'll use 90% because 90% is one of the ones that you're going to see a lot of. You're going to see a lot of 90%, a lot of 95%, a lot of 99%. So let's do 90% confidence. Okay, 90% confidence. So we're going to compute the Z star. And here's, you don't need to do it this way. In fact, once you compute it once, you never have to compute it again. You have the number, and we're going to be using it so often that you really shouldn't memorize it. But let me explain where it comes from. I want you to imagine a normal curve. Okay, a normal distribution. And I want you to imagine cutting off 90% of your data. So this is 90% of your data. How much data is in the right wing? What percent? 5%, right? So Z star is the number that cuts off 5% on the right side. So let's calculate that. Let's take out our TI-84s and let's do second vars normal CDF. Oh, sorry, try that again. Second vars inverse norm because we're looking for the Z. And I just did it. What do you guys get? Hopefully you guys remember this. How do I calculate the Z knowing the area and that we're dealing with a Z normal, which is a specific mean and a specific sigma? What do we get? Who remember?
What order do we type them in?
I'm sorry?
What order do we type them in?
You're going to type in 0.05, which is the area. Or if you do it on the left, 0.95. Right? You're on the left. For you, it's
Yeah, mine said
0.95.
83. Okay.
And then what's your mean going to be?
Is that less than 90%?
Mean is the number in the middle, which you're not going to see anywhere on this page. We have to remember it from what we've done in the past. What is the mean of Z? The mean of Z is 0. And what is the standard deviation of Z? It's 1. Those are fixed. That's what Z is. Okay, this is the standard normal distribution. So if you do 0.0501, or in your case 0.9501, this to the left, you should get what Mary wrote, which is about 1.64. And hopefully you got that. So anytime now for the rest of the course that you are dealing with 90% confidence, you know that your Z star is 1.64. Fact, memorize, write down, do something. But this way you never have to calculate it again. Yes, Angelica, go ahead.
So I got 1.64 as well, but I got mine negative. Is that?
Because you put in 0.05, right?
Yeah.
Because your calculator actually found this point.
Oh, okay. So am I supposed to do like to the left?
So either do 0.95 because you went all the way to the left, or just take your negative and get rid of it because it's symmetric.
Okay.
But either way, Z star is positive 1.64.
Okay.
And just while we're here, if it was 95% confidence, because we're going to see this number also. If it was 95% confidence, then what would be the area that would be cut off in that case? It would be 2.5%. So calculate your Z star for that case. What's our Z star for cutting off? By the way, Angelica, your hand is still up. I'm not sure. Do you have another question, or do I just have to turn it off myself?
Oh no, I'll lower it. Sorry.
I just want to make sure I answered your question. So, what is my Z star for 95%? $1.96 is correct. And last one, because these are the big three that appear so many times throughout the course. Let's also do, if it's 99%, how much is cut off if you do 99%? .5%, that's correct. And what would my Z star be in that case? Oh, I'm sorry, Luis, I see it there. I missed it, but it is 2.58. So these are the three big numbers: 1.64, 1.96, 2.58. I don't memorize them personally because it only takes me a few seconds to use my calculator to get them. Plus, when I do get them, I get a lot more decimals, so I have a little extra precision that I always like. But if you want to memorize them or have them written down somewhere, these are going to pop up quite often. Are there any questions on how we got these three numbers?
Could you go over how to do it on the calculator again?
So which one would you like me to do? Because they're all the same with just different details.
95%.
Okay, so 95%. That means the inside is 95%, right? Which means how much is left over on each wing if the inside is 95%? I'm asking, this is not hypothetical. How much is left over on each wing if the inside is 95%?
Are you asking everyone?
Well, the person who's asking me. I don't know names to faces, and I don't know anyone's faces except Leanne, hi. But everyone else is just too shy. So for the rest of you, if you're asking a question or ask me to do something, then yes, I'm addressing you, the person who asked me. If there's
You said
95,
2.5.
it's 2.5%. So all we need to figure out is what number cuts off 2.5% on the right side. So go to your calculator, do second distribution, second DISTR, you see it?
Yeah.
And go down to the number 3, inverse norm.
Mm.
You there?
Yeah.
Okay, what do you see?
Area.
Okay, so put in 2.5%, which is 0.025. What's your mu gonna be? What's your mu gonna be? What's the mean? Anyone there? What's the mean? Okay, the mean is 0. This is Z, the mean's always 0. Sigma is always 1. And then just calculate the area or calculate the number, and it should give you 1.96. Now, the other one, which is the T, we're going to wait for later because this chapter is on the basics of confidence intervals. And the T stuff is a slight complication that we're not quite ready for, and we'll be ready for it soon. But this is the formula back here. This is the formula we use for creating a confidence interval for mu in the case when we know the standard deviation of the population, when we know sigma. And the questions that the book asks will be very clear on whether or not you know sigma or you don't know sigma. It'll say something like, given the fact that we know sigma, or something like that, so that you know sigma. It'll be very clear. X bar, you calculate, N is your sample size, Z star is one of those 3 numbers, or possibly another number. If I give you 80% confidence or 92% confidence or something else, you should know how to compute them. And then sigma comes from the population itself. Okay, does that make sense? Any questions yet on anything that we did so far? Okay, now, when you look at this confidence interval, which I'm going to rewrite, so rewriting. Yeah. So we have 2 things going on here. X bar, we call a point estimate. If I had to give one guess as to what mu is, one specific number, why would I pick anything better than what my sample mean is? It is a point estimate. It estimates the true value by giving me a point. But another way of writing this is X bar plus or minus the same thing. Which means in my interval, where does X bar actually land geometrically, where is my point estimate when I actually graph my interval? Here's the number line. And here's my interval, my confidence interval. Where does X bar land on that confidence interval? It's directly in the center. X bar is directly in the center because you add and subtract the same thing to get the two sides. That thing that we add or subtract, this guy, is called the margin of error. So you have your point estimate, which is the center, and then plus or minus your margin of error. So let's do an example. I am going to stop sharing this for a second and start sharing this. Okay. Everyone see it? Example 16.3, right? It says, does the expectation of good weather lead to more generous behavior? Does the expectation of good weather lead to more generous behavior? Psychologists study the size of the tip in a restaurant when a message indicating that the next day's weather will be good was written on the bill. Here are tips from 20 patrons measured in percentage of the total bills. 20.8%, 18.7%, 19.9%, and so on. Okay. We want to estimate the mean tip for comparison with tips under other conditions, which was not given here. Now, look at this last sentence. As part of the simple conditions, suppose that from past experience with patrons of this restaurant, we know that the standard deviation is sigma equals to 2. Notice how they are giving you sigma. Yes? Okay, so sigma is equal to 2. What is n? What is my sample size?
Is it 20?
20. What is my confidence level?
95?
95%. It's given there on the bottom. I didn't read it, but it's given there, which tells me that my Z star is equal to what? $1.96. Actually, the book, just so you know, when they give these values here, they write it as 1.960. They're using 3 digits. I'm going to use in my calculator 1.959963986, but it's all the same. No, 1.64 only is for 90%. This is 95%.
What did you put in your calculator?
I haven't done anything in my calculator yet. I'm just writing the information down.
Well, then how did you get that number?
Oh, well, we did it a few minutes ago, didn't we?
Oh, right, yeah. Okay.
95%, we get 1.96,
Okay.
right? So we need X bar. The only thing I need now to finish my confidence interval is knowing X bar. Let's calculate it. Where's it going to be? Where do I go to find X bar? Anyone remember? Statistics.
No. Can you go to graphics? Put it over.
Graphics. She wants statistics, descriptive statistics.
Oh, yeah.
Columns, percent. That's how it's labeled, percent. Calculate. Oh, hey, we got everything we need. Or do I? Yeah, there we go. X bar, 22.21. Correct?
Yeah.
Now, do I have everything I need to calculate the confidence interval?
Yeah.
Great. Let's do it faster. Let's go to statistics Z, not T. We'll get to that later, but Z. One sample or two sample? Well, you say two, but what's the second sample here? We have the Tony patrons, that's one sample. And do we have a second sample to compare it to? It's one sample. Percents. Where do you think I go now?
You put in the standard deviation?
Nope. Look closer.
Oh, you want to go to confidence interval, not hypothesis.
Okay, confidence interval. What confidence will we like?
95.
Oh, good. And you're right. Sorry, we did need to put in standard deviation,
Which is 2.
which was 2, because they had to give it to us. It's not from the sample, but it's from prior knowledge. And then where do I go now?
Calculate?
What is my confidence interval?
21.33. Why does it give you 2?
Well, it's got to give me the left edge and the right edge of my confidence interval. So what's the left edge?
21.33.
21.33. What's the right edge?
23.09.
Okay. So what can I claim as a result in the context of this problem? Give me an English sentence about the results of this experiment. Excuse me. Remember what we're trying to do here and look at the results. And somebody give me an English sentence. It can have some numbers in there because, you know, this is a math course. But give me an English sentence that sums up what we just did here just now. Anyone? Sum it up in words. What did we just do? Tell you what, I'll start it for you. We are 95% confident that. Now, someone finish it. We are 95% confident that the tips will be Okay, I like the answer, but that's not correct. But I like you trying, I'll tell you that much. Much better than, silent staring. Remember, Mary, what's the, well, go ahead, what?
Like the confidence level, like this is the average tip interval from 21.33 to 23.09. That's the
Oh.
average of tips.
But how is that in the context of this problem? Oh, let me rephrase that. What is the goal? No, I like your Flower, good try, but no, that's not correct either. In fact, Flower, the point of estimation. Okay, so Nikki, there you go. The whole goal of your sample is to figure out mu, to figure out the population mean. That's the purpose of all of this. So your answer, your conclusion has to be about what you're looking for. We're 95% confident that the true mean of the population, the true population mean, you don't really got to write true, but it just emphasizes that the true population mean is somewhere between 21.33% and 23.09%. Flower, you said that the point of estimation will be between them. I know the point of estimation is 22.21. I'm 100% confident it's 22.21 because that's what the math gave me. I'm not worried about that. And yes, Mary, the words at the end is the context. When the weather is written on the receipt, that whole thing. I mean, you should certainly include that. I'm focused more on the math part. So we're 95% confident that the true population mean is somewhere between 21.33% and 23.09% when the weather is written on the receipt. Your conclusion needs to be about the mean, what you're looking for. Otherwise, what's the point of any of this? Does that make sense? Everyone else, does that make sense? Okay, it's all about the population mean. That's what we're looking for. Excuse me. And it's nice that Crunchit was able to do it for us. But you know what? Let's say we didn't have Crunchit. Let's just confirm very quickly, based upon the numbers that we do have, that we would have gotten the same thing. So without a calculator or without Crunchit, we get 22.21. Oh, whoops. We get 22.21 plus or minus 1.96 times 2 over the square root of 20. Let's quickly do that on our calculator. I get 21.33 and 23.09. So I do in fact get the same result. So Crunchit can do it for us, but it's nice to know that we can do it by hand as well. Excuse me, does that make sense? Are there any questions on the one situation that we've done so far, which is again, finding or estimating the population mean when the population standard deviation is known? It is one situation. We're going to end up with like, I don't know, like 8 different confidence interval cases. And we're going to end up with a bunch of hypothesis testing. Oh, one more thing though. One more thing. We did it by hand. We did it on Crunch It. So now let me show you how to do the same thing on your calculator. So who wants to take a guess as to where we go on the calculator? Would anyone like to take a guess as to how we find confidence intervals on the calculator? Well, T-star is something else. No. T-star we haven't gotten to. Everything is Z so far. T-star is just, it's something that we're going to get to later in a later chapter when we start learning all the other types of confidence intervals. But I want to do exactly the same thing we just did on Crunch It and by hand, and I want to do it on the calculator. So who wants to guess as to which button on the calculator I press first? Oh, so you're jumping ahead. You've hit like 8 buttons already. Not 8, but you feel like 2. Celeste, tell me the first thing you pressed.
I hit stat first, and then I went to where it says tests.
Okay. And then down to which one?
The Z interval.
Yes. Okay, awesome. Stat, tests, and then you scroll down to Z interval because we're doing a confidence interval with Z. And when you hit enter, it gives you 2 options. It asks you to input by data or by stats. If we do data, we got to put in all of the actual data. Where do you think I put that in? Where do you think I put it in? Yeah, list 1. But because I have the info already, I'm going to go over to stats. And with stats, they don't ask you to actually put in the data in. They just ask you to put in the summary. So what parameters, what things do we need to put in on the Z interval under stats? There's 4 things that it requires. What are the 4 things? What's the first one that it requires? Sigma, which is what? 2. Next. X bar, which is what? (22.21). Of course, if I didn't know that, I'd have to put it to list 1 to calculate it, but I do know it. What's the third thing I need? N, what's that? 20. And what's the last thing I need? The C level. C stands for what in this case? Confidence level. So what do I put in for that one? I don't put in 95, which will be huge, but rather no, you don't put in Z star. You put in 0.95. Z star is 1.96, but I don't need that actually. The calculator will do that for me. I just put in a confidence level of 95%, which is 0.95. And then I ask it to calculate. And when I do that, what does it give me? You'll notice it gives me exactly the same. I mean, an extra decimal actually, but for the most part, exactly the same. Does that make sense? Questions on this?
On my calculator, I don't see a confidence interval.
You should see a Z interval. When you do stat and tests, what do you see? Start reading them off for me. After stat tests.
After stat, I see mu with the base 0.
Wait. I think you went too far. Stat tests.
Stat tests, and then enter for Z score.
No, no,
I mean,
no,
z-test.
no, we're not doing z-test. We're not doing a z-test. We're doing a z-interval.
Oh,
You gotta
okay.
scroll down to the z-interval.
Okay, I see.
Okay, and by the way, while we're there, everyone, how many different intervals are on the calculator? We've only done one so far, the z-interval, but how many are there?
There's t-interval too.
There's z-interval, t-interval, two sample z-interval, two sample t-interval, one proportion z-interval, and two proportion z-interval. So I have 6 intervals that are on there. And as we're gonna see, 2 of them we can use in 2 different ways. So I believe there's a total of 8 that we're gonna use in this class. But at this point, we've only done one, the z-interval. So don't try to use it elsewhere. Okay? Are we all caught up? Any questions on what we've done so far? Okay, so far it's been why we do confidence intervals and then how to calculate a confidence interval in 3 different ways. Crunch it, calculator, by hand, by the formula. Okay, but we're not quite done with today. We have one more idea, one more question, which is the following. But before we go on, last chance to ask if you want me to do something again, or if you're not sure about something. Otherwise, I move forward. So are there any other questions for what we did today? Going once, going twice, going 3 times. Okay, so next. What if before taking the sample, you wish to choose a sample size so large sample size so large, so large, so that you ensure your margin of error is sufficiently small. So as an example, I wish a margin of error of 0.001. So I wish to have a margin of error of 0.001. What size sample should I use? Okay, so you're about to take a sample. And before you do, you say, wait. I don't know what my margin of error is going to be, but I want to make sure that it's not big. I want to make sure my margin of error is really small, 0.001. In fact, let's look at the last problem. What was the margin of error for the last problem, by the way? What did we get in the last example? What was our margin of error here? What did the math give us? What's our margin of error? 0.88. That's how few people get out. That's a pretty large margin of error compared to 0.001, right? So n equals 20 got me a margin of error of 0.88. So I say I don't want a margin of error that big. I want to make sure my margin of error is small. I want to make sure my margin of error is 0.001. What size sample do I use? So let's derive a formula for calculating the margin of error or the sample size. We know the margin of error is equal to z star sigma over the square root of n, right? That's this thing right here, correct? Yeah. So let's just solve this for n, shall we? Okay. So if I solve this for n, what do I get? Well, let's take a look. I can cross multiply m squared of n equals z star sigma. Divide both sides by m, so the square root of n equals z star sigma over m. And then what do I do to both sides?
You square it.
You square both sides. So n is equal to z star sigma over m squared. So let's calculate what that is for this example, for the one that we just did a few minutes ago. We used 95% confidence. So what was our z star? $1.96. What was our sigma? Two. What margin of error are we hoping for? 0.001. So let's go ahead and calculate what size sample I would need. It's a pretty big number. It's like 15.5 million. Right? You all see that? Okay. So yeah, it would be awesome to have a margin of error that small, but at the same time, it's not really practical. In fact, what do you think is a good margin of error to have that you think might be practical? 0.001 is just way too small. What's a margin of error that you think might be a little more practical? Anyone? What's a more practical margin of error? Pick a number. 0.5. Okay. Within plus or minus 0.5. Okay. Let's go ahead and calculate what a 0.5 margin of error would what size sample that would require. How big of a sample would a 0.5 margin of error require? $61.4656. That seems fairly manageable, doesn't it? In fact, by the way, you obviously can't take a sample of 61.4656 exactly, right? So would you round down to 61 or up to 62? I have 3 61s and 1 up. 4 versus 1. 4 to 1. Those are pretty strong odds. Luis, would you like to 5 to 1? Luis, would you like to switch to the others? You want to stick to your guns? I'll die on this hill. Well, you're not dying alone, Luis, because I'm there right with you. The answer is 62. Now, you might say, I don't get it. I learned how to round back when I was in 3rd grade, and 61.4 rounds down. You don't round up. And that's correct. You round down, but we're not rounding here. We are picking the smallest sample size that ensures a margin of error no bigger than 0.5. Any larger sample would also have a margin of error no larger than 0.5. But a smaller sample will have a margin of error too big. It's not a rounding issue. It's going in the right direction to ensure that you maintain what you're looking for. Dropping to 61 makes my margin of error slightly larger than 0.5. Going up to 62 is in the right direction, not because we rounded, but because we have to make sure that we don't pick any number smaller than 61.45, whatever it was. And while 61 is smaller, 62 is not. So we always go up. Always. Rounds, I use this term in quotation marks, up in this scenario. Luis, way to stick to your guns, man. I love it. Does that make sense? So are there any questions on why we do confidence intervals, how to compute a basic confidence interval, and also how to compute a sample size in advance, knowing the margin of error? Any questions on any of those topics? This was the subject for today, chapter 16. This is the last chapter that's going to be on the mini quiz a week from today. So I know that when I looked at the website for the book, they had chapter 16 actually due October 25th. So I'm going to move this a week earlier to the 19th. And you might not like that, and I don't blame you for not liking it. However, I want this due by the mini quiz so that you are as prepared as you can be for it. And also, I kind of feel that of everything we've done so far this course, this might be the most, I don't want to say simplest chapter, but once you get it down, it's really the most straightforward chapter. There's basically 2 formulas in it and some concepts that are kind of obvious to some extent. Yes, no, maybe so. Everyone? Anyone? Everyone? Nobody. Some people. Okay, so I just changed it to the 19th. I'll make sure everything is visible. So 8, 9, 15, and 16. Basically, all the chapters on the mini quiz, which is due October 19th, they are all due October 19th. So they are all, you have a week for them all from here. But we are going to move forward on Thursday, chapter 17. So even though it's not going to be in the mini quiz, we will start that next time. So I am going to stop sharing